Good evening, everyone. My name is Drew Minkin. I am an ex-Microsoft employee that used to work on the fourth floor here for a couple of years, and for several years before that in SQL support. Last time I was on the stage, it was while we still had our great local hero, Ken Henderson, with me. So since I once experienced his greatness on the stage here, I always have to reflect on that moment here. So anyway, enough sadness for now. So the my keyboard's not working. Wait. It's just slow. I'll do it the old way. All right, so we have, I think, almost 60 slides, and it looks like 50 minutes. So we're probably not going to get through everything at once. I'm going to focus on the data mining and lifecycle management, because if there's only less than a handful of people that have used this in their environment and are interested in understanding how data mining can help their group, then it's certainly beneficial to get some background, and then I'll also be able to give you some pointers. So we'll just jump right in. All right, so data mining is something that's become very popular to discuss. I've seen articles. One of my favorites I saw recently was called "The End of Theory." Anybody read that article? The Wired. Basically, what it is that we've gotten so good with computers' capacity to be able to churn data that there's a lot of vendors that actually do real-time data mining of transactional data. I mean, it's certainly they pay a pretty penny for it, but it is something that is a real aspect of enterprise computing nowadays. And I think that it's it's only become more relevant because people have more data to look at than they used to before, I think. But Microsoft has taken a bold attempt to take what used to be in just the statistics world and bring things into more of a data and application range for users to access here. So hopefully you'll be able to get at least the big picture of how data mining can fit into your organization, or at least the components that you may be able to help use to support it, and be able to move on from there. So the promise of data mining is very significant. It's something that's used in our political process to determine agendas for politicians. It's used in a lot of economic situations for a lot of different work. And so it's something where it's becoming commoditized, and the demand for integrating it into applications is something that you're going to see more and more. Out of the 10 modules that I support in my day job, the most recent 3 actually are looking to take data mining to be something that round trips directly to the transactional system, and also makes recommendations to be able to push reports down to the lowest levels of organization. So it's here to stay, and it's only going to get more popular, I think. So the challenge, though, is that data mining requires a lot of data, and the data itself has to be groomed in a particular direction for it to make sense for a general purpose algorithm in order to use it. So when you're thinking about leaving the transactional world, using integration services in some ways as a pivot to where you're shaping data for a particular use as opposed to for the best performance in collecting it and manipulating it, we see that data mining is sort of on a hierarchy at a higher level than a lot of OLAP or analysis services. And there's a misnomer that essentially that everything has to be in a cube for you to be able to work with data mining, and to some extent there's a dependency that we'll be clarifying, but there's also significant areas where this is a fallacy that we'll be going into. But just understand from a value proposition and level of difficulty and support, performance, things of that nature, data mining is something that adds a higher bar than you'll find in a lot of OLAP situations. So there's 2 general purpose ways. I like to think of data mining more as applied machine learning, and there's different types of ways that you teach a machine. Sometimes there'll be relationships that it will find by itself, or what you consider an unsupervised learning. We'll talk more about those when we look at different algorithms that you would choose for data mining. But associations looking at many different entities. And when we talk about entities, ultimately they'll all map back to some sort of column, so don't get caught up in the terminology there. And there's some sort of target information that you're looking at. Supervised learning is where you're actually trying to find an output or a dependency between a series of entities or input variables, and then have targets that you'll be looking at. So a common one is using for credit scores, but scoring engines themselves are not just specific to credit. It's just a way of breaking down weights and the strengths of different associations. So in general terms, the actual engine that will load algorithms and be able to give you output is tied to analysis services. So it's in some ways similar to a full text engine integration in that there are sub-processes that are dedicated to data mining, but there are some overlaps with multidimensional work, but there are also significant differences in their structures that are unique to data mining. We'll just be able to gloss over those a little bit, but understand that there's a Venn diagram and an intersection, but that there are significant differences between them. But ultimately, under the curtains, there is an XMLA dialect that is using DMX. We'll have some very basic samples of it to take a look at later that you use as an interaction with mining models themselves and with the query language beyond that. So just since we're talking about the newest versions themselves, there was not that significant of an increase like there was with most of the BI tools between SQL Server 2005 and SQL 2008. One of the biggest features, though, to think about is cross-validation, which is basically the ability to test several different models across either different partitions or different data sets that you want to use. So it's a very nice feature. It automates a lot of things you used to do by hand to actually make multiple models and have to aggregate them in other reports. So it's just another feature that I encourage you to use a 2008 or R2 build on that. And for those of you who took the SQL Server 2005 BI TS exam, I'd like to apologize for the large number of data mining questions that were on it if you didn't have that good a score on it. I was actually in the alpha for that, and there was one of the people that was writing a book on data mining at the time, and it was the one person from the team that came to visit us, so there was that kind of weight that had occurred there. So before I move on, are there any just general questions about data mining so far? I know it's pretty basic stuff, but just want to make sure that concretely understand that it's a subsystem to analysis services, but it is unique in a lot of its functionality. No questions? Okay. Yes, sir.
You mentioned data mining and giving the instant feedback to the transactional system.
Mm-hmm.
Is there a case study or is there a business situation?
A case study?
Yeah. Is there an example, real life example?
Well, I mean, you could argue that the majority of what is Google is in itself a very large data mining algorithm, because the Google PageRank algorithm is basically looking at associations between web pages in order to be able to give you a rank that's returned. So I mean, that's the most immediate example of a feedback in that way. Another one that probably most people have had is, anybody had somebody when you've been on vacation call you from the fraud department of your bank? Okay, I guess most of you are working too hard to take vacations, but anyway. Point being is that basically what happens is that they build a model for your income or your segment in the population, and if they see transactions that are outside of that, it may not be full real time, but they're using usually an association or a neural network type of an algorithm to say, hey, we're seeing something that from our history looks like it might be fraud, and so they'll contact you or cancel your card or suspend it and then wait for you to call them. So that's a very common scenario of a use case. Also, if you've ever been to a website that said, if you liked this item, why don't a lot of the people have liked this item as well. So under the covers, it may not necessarily be a Microsoft implementation, but essentially there's been a data mining that's made in association by looking at different categories of transactions to determine that, based on what information it can gather about you, that it will give you that associated data. So So those are some common scenarios there. Any other quick questions before I move on? Okay. All right. So this is in very general terms. I wanted to keep it more in the shape of subsystems that make sense from the tool sets that we all know and love, since this is a Microsoft group, and we're talking about how Microsoft would do these. But you may see up in the corner here there's an abbreviation called CRISP.DM. I don't want to go through the details of it. You can pull it off the slides, but it's essentially a basic methodology that's used for data mining. It's canonical the same way that if you're building cubes and data warehouses, chances are you're following more of a Kimball methodology. For those of you who are power hungry and have large organizations, you may have an Inman model, but generally most people are doing Kimball. CRISP.DM is sort of a way of translating sort of ITIL style of a generic process for data mining that will apply to any industries. And so the one thing that I'd say that's missing from this particular slide is that from a business understanding point, I would probably put all of the actual client tools that are part of the Microsoft BI stack, things like Excel, things like Power Pivot, Performance Point Services, and SharePoint itself, because that's what the people who drive your requirements for anything that you're going to implement are going to be coming from people who are digesting the end products of all of your data here. So you can see that analysis services is not the only piece within a data mining infrastructure for an application. I would argue that the data preparation here, while it may have a small piece from a technical standpoint, for anyone who's done data warehouse design or maintenance, is the most critical part, because you are the system of record for any theories and propositions that come out of your data mining algorithms. And so if you're not doing your job on cleansing letters out of phone numbers or things of that nature, and doing the right job with the SSIS packages we've been talking about this evening, then you will definitely fail. But from my experience, I've kind of been on both sides of the world for analytics, where I've built cubes, and I've also supported infrastructures for other statisticians, and it's important that they know each other's world in that respect. So, any questions on this slide? All right. So again, we have here, and these are just basic summaries of the CRISP.DM thing of acquiring data, cleansing it, analyzing it, or some people talk about this as being the discovery mode for data, building a model where you believe that you have relationships that you can be able to find, and then you test it by putting it in the wild, or by testing it against random data using things like a Monte Carlo simulation, where you'll take random permutations of data and fit to see that your tests actually bear out to be significantly better than a random set of data. Monitor it, refine it, and acquire more data as you need to. So here's a little animation. Sorry about if the lighting's a little bit off on it. But you can see here that just in general terms that a mining model is being created, and then you have a training data set. A lot of times if you're looking at historical data, like a year's worth of your sales data at a company, a common thing is that you'll hold out a certain percentage of rows, maybe 20% or 30%, so that you have a subset of your data that you use to train the model, and then you would add back in a full set to basically see whether or not it can still predict the same conclusions based on the additional data points that it has. So when we're talking about training data, you can think of it as sort of your test set to work with to build your theories. So that's something to keep track of in there. Any questions about this one so far? Okie dokie. Yeah, I know we're used to sort of a very reactive mode and having very clear specifications for a lot of the data world. Data mining is, I think, particularly challenging, not just because you have all the issues of business to technical requirements for every other business intelligence technology, but also because you can only express your results in percentages of likelihood. So everything's got an asterisk and a caveat against it. My favorite story, did anybody read the article about the algorithm that supposedly caused a lot of the subprime mortgage issues? Basically, there was a thing called a a Gaussian copula, which is basically sort of an edge detection on statistical populations that was ballyhooed as a way of taking a way to be able to price radically different mortgage bundles and basically take a path that was computationally very quick to be able to estimate how much risk there was in a bundle. But when it was originally proposed, the statistician said, well, this is great for most of the time, but there are cases where if there's major changes that are all happening at once, that can be a problem to the model. But what happened is that everybody was happy that they could just bundle these things using this heuristic, and they didn't listen to the warnings of the issues of the model itself. And we all know what kind of happened from there. I mean, there's certainly lots of places to point the blame, but there are some people that have tried to throw the statisticians under the bus for that one. Apparently that statistician left the country, is now working for, I think, the Bank of China. Well, you know, from what I heard, there's one country, there's one city, I forget the name of it, but they're basically they say everyone's into real estate because it's always rising. I'm like, well, you enjoy that. We'll talk to you in 10 years and see how things are going. All right, so this is essentially a different approach to looking at a detailed workflow, but this kind of puts it in terms that are closer to data mining algorithms that you would use. But you can see a similar approach. A variable analysis, that's just a statistician's way of saying, looking at, based on a certain column and its relationship to what you're trying to predict, whether or not it's considered a candidate or not for that type of analysis. We will be looking at some of the AdventureWorks models to help, look at this a little bit later. But again, since you're a technical group and I'm not trying to sell you data mining itself, I want to make sure you understood the big picture here. And then so once you have a structure where you've imported the data, you can apply several different models to it. It's kind of like the equivalent of having it within a database and then having different views, just with a lot more horsepower CPU-wise behind it. And so these are several different ideas of how you would look at the model to see if there's different results. So multivariate analysis, it may take a bundle of different columns or variables within your data mining structure to determine the actual output. The main thing is basically look at things that have strong distribution patterns that are consistent and that show up regularly within your analysis. And candidate models, everything needs to be tested. Everything needs to have a lot of scrutiny before it's released. I think that's one of the main reasons why this is something that it's very hard in most organizations. You don't see a lot of statisticians that have master's degrees. They're usually just pure PhDs because they feel like it takes that much paper to get working. But I've had discussions with some of them, and a lot of them are basically just using the exact same models that are built in for just basic clustering algorithms. And a lot of times there's not that much beyond what core algorithms can be able to give you that you can see. So just so that you know what to expect when you're doing this, and again, this goes back to the SSIS part where we're not talking about a different world, we're just talking about a different view of the same data, is that the data preparation, being able to acquire it, being able to cleanse it, being able to aggregate it, partition it in ways that are meaningful and performant, most of all, then the data preparation is the key part, because if you don't have your data structured the correct way, then it's not going to be able to perform well in the data mining, and it's also going to potentially cause errors. So these are just some other examples of acquiring raw data. I don't think there's a lot that we need to discuss to this group about acquiring raw data, because that's normally where SQL comes in. But these are just other pieces that we wanted to touch on very basically here. Are there any questions at this point? Am I going too fast? No? Okay. All right. I know we got a lot to cover, so I'm trying to gloss over where I can. And again, I wish I could take credit for more of the slides on this deck, but a lot of them were taken from Paul, I think it's Paul McAllen that's in the data mining group at Microsoft. But anyway, so this is a view that's a little bit more detailed to give you an idea of what's happening within the predictions itself. more on the DMX level, when a query comes in, all the different layers that a DMX tree will go through. So there's not, the same way that you don't have execution plans in analysis services, you're not going to have execution plans for data mining. So from a pure performance standpoint, it's not as well vetted a product as SQL in being able to tweak things and be able to build internal structures, which I think may sometimes be something that could be used in the future. But again, these just give you an idea of some of the heavy work that's being done behind the scenes to give you the pretty pictures that we'll be looking at. So, a case is basically one particular set of attributes that you may want to look at, and then there'll be a nested case we'll talk about a little bit more, or for a particular population, all the different interactions that occur, or similar to, if you're looking at a particular product, all of the sales orders that it actually occurs on would be the nested pieces of that case. And converging is really just when it's found enough results to be able to report something back that's meaningful. So the goals of refinement are to reflect changes over time. This is, again, we're trending. Having analysis services can be a major benefit, although you can do time tracking and other type of aggregations like that within SQL. Just be careful about your speed and your storage usage. And it's a good stage for before you pre-process. And this is a general case for how scoring engines work, but you're basically trying to classify different policies based on, some of the things may be business requirements as far as what you can and can't be able to put into a data mining algorithm. Other things may be stuff on as far as what the results show from looking at the analysis there. So as far as, we'll flip into the actual project so you can see what data mining looks like from building a project and from browsing a model in just a minute here. But these are the general structures and the tool sets that you'll be using in order to accomplish data mining within SQL Server here. So let's go ahead and flip in. Now I want to warn you that if you are using Visual Studio 10 for right now, if you're looking at the release candidate or anything, it will break some of the data mining add-ins that are used by Excel 2007 because there's basically R2 is at a pre-release standpoint, so I guess some of the assemblies are stomping on the GUIDs behind the scenes. So I encourage you that we'll talk a little bit more about the data mining Excel plugin a little bit later, but something I wanted to show it in more detail, but I didn't realize that stomping was occurring until today, so we still got plenty to look at, don't worry. Any questions while we're waiting for this to come up?
Do you recommend any books for 2008 data mining?
There is one book by Wiley & Sons that's just SQL Server Data Mining 2008. That is canonical. It's written by the Microsoft team, and it goes through very detailed examples and explanations of the different properties of all the data mining algorithms, and also gives some performance tuning tips. So it's definitely the canonical book. I really haven't seen other books that would be peers to it. So it's hard to go wrong when it's directly from the source, so to speak. All right, so what we have here is the R2 version of the AdventureWorks Data Warehouse Cube. I'm going to just hide the more cubey things. But you will notice that because there is metadata abstraction and it's a tool that you may have disparate sources that you're building together for your your data mining work that you're doing. We do still have dependencies of a DSV, so those don't really go away. Just show of hands, does anybody use DSVs with their integration service packages? I didn't think so. Just thought I'd check. Always looking for somebody to do that stuff. All right, so here's just a sample. I mean, you can see that this is basically just a DSV that you would see in any type of the reporting services projects, analysis services, what have you. But where you start to see the real usage is when you build data mining structures. Now, again, a mining structure is sort of the equivalent to the raw table or the base data that you're going to use as input for a variety of data mining algorithms. And the output from a particular algorithm is going to be a mining model itself. Okay, so you have to have one structure, and then one structure will have many mining models associated with it. It may not have multiple ones, but it's a one-to-many relationship in that direction only. And so the targeted mailing is a relatively simple set. Sorry, having problems getting a handle here. In where you have one table, or in a lot of statisticians' terms, they'll call this just the model fact table, because it'll essentially have, it may be something where you've done joins behind the scenes to create a view between your the dimension tables of your star schema, what have you. But you can see here that they basically taken out so that all of the attributes are in one row instead of having to do lookups to see whether they've had education in certain areas or not in this particular example. But what you'll find is more common in data source views for mining models is having a series. Sorry about that.
You said a mining structure has many mining models. Do you have to
Right.
define a mining structure?
Yes, you have. Okay, basically, the process is you start with a data source view that is your raw data from a view or a table. Then you build a data mining structure, which is a subset of that data, or where you build joins that will actually be used as input into the data mining infrastructure of analysis services. And then once you have a data mining structure built, then you can start to add mining models where you choose different roles for different variables and then look at the actual results through that mining model. So it'll be a little clearer in the example here. So DSVs are sort of a universal BI concept within SQL Server, or the whole SQL Server BI stack here. This is a sample of where you're taking essentially having dimensions. In this case, we've got dimensions associated with a customer here. Customer here that are associated to a case that we're seeing with actual measures within a cube here. But even though this example that comes with analysis services is using a model that's based on cube attributes and measures, you can still use relational tables as your data source and for building your mining structure. Okay, because it's only once it's in a data mining model that it's actually, or a mining structure, that it's a dependency within analysis services, and even then it's a separate structure than a dimension or a measure group. So these are all of these are all the relationships that are possible to build into a structure, but for this particular mining structure, we have a subset that we've chosen that we see here on the left. But from that structure, we want to take a look at different ways that that data may be structured. And so that's where mining models come in. Because in this particular sample, we have two different algorithms, and we'll talk a little bit more later about what these algorithms can be and what they do and why you choose different ones. But you can see here that for the association rules, there's very little information that is passed in. In fact, you have the key value, and then you have the subcategories that you're basically trying to just predict on. So there's not a whole lot that's in that one, but this one has a lot larger sets in it. And I think if we look at the market basket, this has even more models in it. There we go. Okay. And so for targeted mailing here, we have 4 different algorithms that are used. So there's a binding of a particular algorithm and its parameters to a mining model, but you can have multiple mining models for one mining structure. A little bit clearer now? Okay.
Does the data flow through this way?
Well, you could look at it more as a fan approach, is that when you do the equivalent of sort of an ETL load, or when you process a mining structure, you're taking it from your source data, and at that point it is now in a data mining friendly format internal to analysis services. And then what happens is that you define from that mining structure, you could say that at that point that a mining model is essentially like building the cube itself and processing it. And then a mining model is where you choose a subset of that data like you would in a query, and then look at that and then based on those parameters decide what actual output you would want to look at there.
You mentioned that all those were different algorithms, so there's different columns for all different algorithms?
No, yeah, the columns are all different algorithms, that's correct. You can see here that this is Microsoft decision trees, here's Microsoft clustering.
What does that mean? Does that mean can you define your own, first can you define your own algorithm, and second, what do they mean?
You can define your own algorithm, although I would say is not for the weak of heart. In the 6 years since 2005 almost came out, I've only seen one significant addition of a new algorithm that didn't come from Microsoft directly, and that's available on the SQL Server data mining site. If everyone's been to SQLServerDataMining.com, but for one thing, you're relying very heavily on a very elaborate mathematical model that has to be well vetted from a testing standpoint. So it's really something that has to be beaten up very heavily. So Microsoft sort of took the path of resistance between SAS and other tools and saying, okay, look, we're going to try to instrument very complicated mathematical models in ways that people can actually use them very easily. So most of the time what you'll be doing is just sort of turning the knobs on algorithms. You wouldn't actually be writing your own. And there's a section that we'll hopefully get to that will show you, at least there's 2 slides we'll get to on choosing data mining algorithms. All right, so now what we're looking is we're going to go ahead. And since I recently rebuilt this box, I'm right now having it deploy everything. Might be running a little bit slow. I'll come back for it in just a second. All right, so again, testing is something that we know something about. Particularly if you worked in BI, you know that you have to check anytime you go from your relational to your denormalized to your cube. You have to have checks and balances on your data, and it's even more important for testing because you're trying to prove something or have a value add of a theory that you have to be able to prove. So one of the tools you have is to build confidence in your model is what they call a confusion matrix, where basically you take a look at the output once you've decided you have one and decide, okay, when was it right and when was it wrong, and then you can essentially look and decide how good your model is. So this is an example of basically how you would put those basic terms of, when it told you it was a non-buyer, when it was a buyer, and vice versa, and come out with a number that's sort of a parlance within stats and data mining circles. So that's an actual technical term, confusion matrix. It's not just, I didn't know what color to choose. I had that slide already. All right, so nested tables, again, we saw a little bit of that in the earlier model. One of the nice things about why that data mining has over SQL, this is really more in 2005 and 2008, was that for handling sparse data, it was a little bit better than SQL was. And so that's just something structurally that we want to look at here. So this is another example of, a case, which is, a particular customer liking a movie, and then these are the attributes about that customer. And so behind the scenes, the data mining model will merge those and then do analysis based on those cases, and then give you information about those attributes and people's most likely association with a particular movie. This actually came out of a data mining survey that was done internally at Microsoft during the SQL 2005 production cycle, or development cycle. So yeah, I can see we're starting to run out of time here, but I just want to, a lot of this, I usually try to design these decks as reference for later on so that you can use it. I don't have a lot of links in here, but essentially SQLServerDataMining.com is probably the best site for learning anything on data mining because it's maintained by the product group. And it's not updated that frequently, but it has pretty much everything that you need. A lot of great good code samples for client-side work. And another nice thing is that when we can look at data mining models here. Let's see. Okay, so it's still processing. And so again, here we have you can see that in some ways this looks very similar to a table structure behind the scenes. At the bottom, it came off the slide, but it would say using a particular mining model behind it. And then this is essentially what you can do ad hoc if you're building applications, is take data from one source and then look either add it to your training model or evaluate that data against your training model to see whether or not the same, based on the model that you have, what you can say about those same attributes. But again, metadata is always the key, so you have to make sure that everything matches properly when you're being able to put everything in. So that's the bugaboo of our existence. So here's some sample output of essentially a probability of a particular, essentially we're trying to predict the college plans and their probability, and these are different aspects of their the population that you're trying to summarize here. Okay, all right, so we have a model here. We'll play with this a little bit more. So this is using a clustering model, which is essentially looking for population densities for different attributes. And so just to review here, we're looking at these different type of aspects of the population. Clustering is a very common piece. It's a lot of what marketing does, or if you've heard of micro-targeting in the political process, a lot of it is using clustering algorithms to try to determine, based on dozens of different attributes from a population, where there are nuggets of people that concentrate. So we can see here, based on these particular aspects, that we have defined about 10 different clusters, and the profiles here give you an idea of what actual attributes went into a particular clustering model here. So you can see there's basically, it's taken a continuous value or something that has many different values in a range, and it's bucketized them into concentrations that it finds. That's a very key concept of, it's slightly different than what we're used to, because most of the time you think about there being just a unit value of a key and then a roll up within a dimension, but data mining works very well with cubes in that you can basically use this aspect to create secondary hierarchies for a lot of your dimensions that are based on actual analysis of the data. So it's not just choosing arbitrary 100-point bands of a credit score. You have actual populations with more meaning and different credit values there. So you can see here that within a particular cluster, it shows the distribution of certain values here. So for example, here you can see in cluster 6, they predominantly have no children here because of the blue. So you can see it gives you a very, if you think about what it would take to try to build something along these lines within SQL, you can understand why people build other engines for this type of work. So I'm going to go ahead and skip ahead just to the choosing of the data mining model, because at least that way it gives you sort of an overview of some of the use cases and the work that you would do with with data mining in your organization. So these are general terms to think about. I have a grid that helps you decide as well, but these are common terms that you'll see. And I have here on the left-hand side the names of the actual algorithms that are bundled with SQL Server, and these are general categories as far as of use cases that you may have. Classification is usually just where you're trying to look for a population and its behavior. Segmentation is something, or classification is what you consider unsupervised learning, where you're just seeing where the basic relationships are. Segmentation is usually where you're trying to tie a particular set of data to a particular output, like which people are more likely to buy a particular product, for example. Estimation is looking at different statistical patterns that are seen within your data and trying to determine the prediction of what's happening. One example is the code that Goldman Sachs was doing for for high frequency trading was actually a very efficient and massive scale use of neural nets behind the scenes. Association is trying to build relationships between data just to see likelihood for people to buy, things of that nature. Forecasting is specifically associated with time series. SQL 2008 added a whole new set of time series algorithms that we didn't have in SQL 2005. And text analysis is a very sort of general approach of what text data mining can do, looking for relationships between words and in different documents that are put into a data mining model. And so these are common areas that they're used there. And then exploration is just when you're trying to understand what a data set looks like, common areas. And on a more technical level, these are different properties of the same algorithms. Drill through is the ability to take from going at the very general level of the summary of your population and being able to drill through into any details on a row level. PMML is something that really is a sort of lingua franca within data modeling. If you're working with SAS, if you're working with SPSS, these are forms that you can take your definitions and be able to import them and also export them and import them in for those particular algorithms. And the interesting point that I wanted to make clear about here is that you can build a dimension that's in analysis services that's available to tie to facts and measure groups and things of that nature, but not all algorithms will actually work that way. And so you not only have a dependency where you have relational output, there essentially is no multi-dimensional output for all data mining algorithms. So just wanted to differentiate that there. And so just to look very quickly at these different algorithms here, classification is looking for risk analysis, regression a lot of times to try to predict profitability, association seeing if there's multiple variables that may be involved, and this is sort of an example of where you can find different variables. So in this particular case, the data mining structure had 3 variables, and it's breaking down the structure in the likely patterns of the relationship between values within your data set there. And while this list is fast, when I was at the first BI conference, one thing I was told by a Kavat was that naive Bayes is actually the fastest data mining algorithm. It's also, in some ways, the simplest, which is one of the reasons why it's the fastest, but it's something that usually is a good way to help triage your data before you go into more complicated pieces. You can try to narrow sets and be able to drive some value add as well. So I want to leave a little bit of time for questions at the end here, because we have hard cut at 8:30. Okay. Yeah, I know it's getting late. And again, it's really not fair to ever try to talk about this stuff in one session. But it's interesting stuff, and it's always fun to at least get your toes wet in something if you're bored of, doing lookup operators and dealing with aligning indexes for your partitions. So these don't work, but essentially there's a great feature of having analysis services as a data mining sort of general tool, where if you have the data mining add-ins for Excel, you define data as a table. Does everybody know what I'm talking about when you define data as a table in Excel? Okay. So basically, if you have data in a table in Excel, you can actually take your data as the actual input, and it will round trip it into basically create ad hoc a DSV, a data mining structure, and apply a data mining model that you choose, and then give you the feedback directly in Excel. I really wished it worked, but like I said, I didn't realize the 2010 thing would break it. Of course, if I repair my DM add-in, it says it is repaired, but there's essentially something beyond repair right now on my machine. So, but anyway, it's a free download. The one thing is that you will need to have a 2008 or R2 install that has analysis services running. You will have to be able to do what's called to create a session model, which is the idea, essentially sort of the equivalent of a temp table within data mining. And if you're opening these up to a lot of people, I would suggest you put them on a server that is not your production piece, because there's no such thing as a free lunch. And if you can think of essentially, you're building this is something that they're trying to push more into the power products as well. But it can be pretty expensive CPU wise. But this basically takes you through in a much more business-friendly and less technical approach to understanding data mining models. And so it's a good springboard once you have everything set up and you want to start playing with it. And also bring in your own data, particularly if you're admins and you want to try to predict log growths and storage allocations. The time series stuff is very, very useful. So we got about 5 minutes left from the hard cutoff, so I just want to see if there's anything in particular that people were passionate about seeing that we didn't get to, or any questions, or if just the pizza hit us so hard that it's Snoozeville from here. So always great to get a laugh at 8:30 at night on a technical subject. So, question?
Where can I get more information on challenges and opportunities in data mining?
Well, I think the opportunities are pretty clear. Just to give you an idea, SAS is sort of the 800-pound gorilla in data mining. If any of you have worked with it, if you can imagine if PowerShell could give you one interface to be able to type in your data mining, your metadata and a scripting language that understood those sets, and then be able to have it spit back and then dump into mining models, you can understand the attraction of that kind of approach, because we have to build it in 3 or 4 different places, and it ends up looking like a Rube Goldberg machine at that point. So that's certainly definitely the challenge is that these are built, but SAS is designed mostly as an analyst tool. So the challenge is to be able to take this great enterprise infrastructure that Microsoft made to be able to have all these APIs, all the great server backend, and be able to get adoption and be able to have it be a peer tool to SAS is the opportunity, I guess, from a mind share standpoint. Because Microsoft has done great work as far as getting Cube adoption, but data mining is so specialized, and also people are. Donald Farmer, I think, told me once that when statisticians are born, they're handed a copy of SAS, slapped on the ass, and sent on their way. So, that's a tough thing for everyone else to break into, but we're trying. So, any other questions at this point? All right. So, just as a show of hands, does anybody feel like they have a big picture idea any better about data mining at this point?
Nobody raise your hands.
Well, I fulfilled my obligation of filling an empty slot for the user group at the very least. So in that way, I've succeeded. But seeing any hands helps me. This is not an easy topic. It's something where I post very regularly to the SQL Server users group, posts on all sorts of subjects. So if someone decides to get the passion and look at this and have some questions, I'm certainly happy to help you at least on your way if that comes up. Are there any other questions at this point? Yes, sir.
If I build a data cube,
Mm-hmm.
beyond that, what we just saw there.
Yes. Basically, when whether it's a measure group that has its associated dimensions, or if you have a table that has a primary key, foreign key relationship, those are all from a data mining algorithm perspective raw data that still has to be put into a structure and then have a mining model built over it. Okay, so. And it's not something where it's required that it live in the same cube, but you can understand from data going back and forth that it helps to keep it its own memory space. So, and also, for those of you who have done aggregation work, when you're trying to look at large sets of data and aggregate their trends, there's a lot of work that analysis service can do for you that has benefits over SQL Server. However, there are some algorithms that play better with having the other aspects of the SQL engine that are easier to manage for memory management and looking at strings and things of that nature that are a little bit easier to work with. So I would, when I had Eugene Asahara come out to our site for helping us with data mining, he was a global architect in data mining, and he said that he recommends you start with relational data as your source, and then if it starts to get slow as you start to build it back, then start to build larger data sets, then move things into cubes. But there are some algorithms work better than others in it. Basically, the rule of thumb is if you can see a data mining dimension, that means it's something that's usually a little bit friendlier in an algorithm to cubes. in there. So, excellent question, though. Thank you very much. Any other questions? All right. Well, then it's really hard to do anything else at this point, so I'm just going to end it a little bit early. And again, thank you very much for all attending, and I hope this has been helpful.
I'm sure you clap while he's recording.